Let's verify this identity. The strategy I'm going to use is pick the more complicated side, which is the left side, and simplify it so it looks like the right side. And before I even begin, I'm just going to make a couple of notes to myself. For starters, I see secant appears within the identity, and I know its definition is 1 over cosine of x. I mean, you could write this down. I'm kind of just like thinking that. I'm guessing I might have to use this identity at some point. Also, I'm seeing sine squared, and this is making me think of the Pythagorean identity. Sine squared of x plus cosine squared of x is equal to 1. Potentially this might show up in some way within the proof. So, all right, to begin, I think what I'll do is on the left side, there's a secant of x in both terms on the left. I'm going to try factoring it out. So I have secant of x, and I'll set up some parentheses. So this side is equal to secant of, and what's left over will be 1, and then just sine squared of x. So it's 1 minus sine squared of x. And I'm looking at this piece here, this sine squared of x and this 1 minus. Well, I see in this identity, if I subtract sine squared of x to the other side, so if I subtract this from both sides, I get that cosine squared of x is equal to 1 minus sine squared of x. So 1 minus sine squared of x is this. It'd be much simpler to write it as cosine squared of x. So I'm going to replace it. I'm going to say, well, this is really equal to secant of x multiplied by cosine squared of x. So already this side is much simpler. There's only 2 trig functions. Next, well, I know secant is 1 over cosine. This means I can place cosine into a denominator on this term here. So to do that, I'll do it in a couple of steps. But secant of x is 1 over cosine of x. That's being multiplied to cosine squared of x. We can really multiply this into a single fraction, 1 times the numerator here, and then the product of these 2 denominators. I'll write that as cosine squared of x divided by cosine of x. I don't need to include these parentheses anymore. So where do we go from here? Well, we have 1 power of cosine in the denominator, and there are 2 within the numerator. So here we can cancel. We can say this 1 cosine cancels one of those, and we're left with a single cosine of x. So here I just took the left side, I worked my way through it, and I made it look like the other side of my equation. This is enough to verify the identity. I guess I'll note that, there might be more than one way to, verify or prove this identity. Like, for example, your first step could have been, well, here I see sine squared. Maybe I could have replaced it with 1 minus cosine squared of x. I'm sure you would end up at the same result at the very end, but here's one way that you can verify this identity. So there might be others, but this one worked.